So you did talk today on OT threat response. Definitely want to touch in on that. Just give me kind of maybe a characterization of like the complexity within an OT environment and how that complicates threat detection for you. I know there are a lot of proprietary technologies, a lot of legacy technologies, a lot of stuff that has to be taken into consideration.
Sure. Thank you. Well, to begin with, the OT environment includes most of the components that you would see in an IT environment. So you have server infrastructure, you have network infrastructure, you have applications, certainly, other types of software. But in the OT world, we have a bunch of complicating factors. And so we use a model called the Purdue model, which is a representation of the different types of systems that exist at the functional levels in the operating environment. So we have devices like pumps and actuators, and they have controllers, input-output cards that control them, utilizing what we call protocol languages, some of which are very secure, some of which are not so secure. These are in turn utilized by engineers and others at the workstation level who interact with these systems for the purposes of operations. For instance, operating the pumps, operating the actuators, and what have you. And then the existing infrastructure above that, right? The typical network infrastructure that you see, and then the server and storage infrastructure. So the way that these systems communicate with each other, the behavioral characteristics of these systems are very unique in the operating environment, much more complex. Everything from the discovery of how these devices are within the network, what their attributes are, what the behaviorals are, and God forbid anything should happen, how you remediate and recover and restore from those systems. So in the OT world, it's a lot more complicated than in the IT world. It requires a lot of diligence, a lot of internal cooperation between security teams and operating teams, and it's become a lot more sophisticated of a security program than what we've ever been experienced with in the past.
And that's due, I'm sure, to connectivity and a lot of convergence with the IT side of the house too,
Exactly.
right?
And we find that there are a lot of tools out there that can help us. And certainly in the last year or two, there has been a real surge of tools that are available for us to help manage all types of risk at all types of levels. And so we've been trying to concentrate our efforts on finding tools that do multiple things for us, tools that are represented as doing those things, tools that actually do those things, tools that have potential to do things that maybe even the provider of the tools don't know about, and then tools that are developed by teams of people who have an open mind to the opportunities of where their tools could go from an R&D standpoint. And that's where Claroty fell in with us, is that latter category that we're able to utilize the professed functionalities of the tool, but more importantly, we're able to work with teams within Claroty to develop much better functionality, much more important security initiatives that we have across the board, across our organization. And that research and development component makes Claroty a far different provider of security monitoring and other functions for us than the other competitors that are out there.
And so for OT threat detection, for example, where does it make most sense to monitor? Is it at that communication layer with all those protocols live? Because
yeah,
I've heard some of the devices characterized as kind of like dumb devices. They're just like single purpose. And does it make sense to monitor there as well?
Sure. So for a long time, many of these systems utilize a protocol, a language that simply is not secure, right? There's different examples of these kind of languages that are not secure. And so sometimes a lot of what we have to do is not just look at securing systems, but actually updating the systems to a completely new language, completely new hardware, completely new software. In order to do that, we have to have a real robust view of the behavioral characteristics of those systems. What assets are talking to what other assets? Why are they talking? Should they be talking? Shouldn't they be talking? So we have to work closely with the operations people to find out why these systems, why these assets are talking to one another, and whether they should be, and if they're not, then what do we do about that? What kind of security measures do we put in place? Is the importance of those assets, those systems, so small, so minor, that it's not worth our effort to make a lot of effort?
Sure.
Or is it such a high-risk system that we need to do something immediate? Should we segment that system? Should we wrap it in additional security controls and end user controls and things like that? And so in order to do that, we have to have a real robust view of how those systems function. And to do that, we have to look at how they communicate with each other. Why, how, when, where.
Yeah.
We need to know all this stuff. We need to have a way to represent that stuff, especially in an organization as large as ours. We have hundreds of systems and thousands of OT assets, thousands, just because we're such a large organization. So we have to be able to manage that. That's just a whole lot of information, and we have to have a way to manage the information. So the information management component is the real value proposition of how we've set up our program.
I would imagine the question you maybe want answered most is, should whatever it is be talking to the outside world or to some other component?
Or to one another,
Right.
right? Yeah. So for instance, we have a lot of bridges and tunnels, right, that we monitor. 6 million people a day utilize Port Authority systems. And should this bridge be talking to this airport? And the answer would be presumptively no, it shouldn't be. But then you have to ask why and how did it get to that? And so I think when you start looking at those kinds of things, you see, well, somebody did something back in 19 something or another, and it was just a temporary thing, and they never went back and undid it or redid it or something. And when you get into those kinds of questions and seeking those kinds of answers, remediation becomes an expense-driven proposition to manage the remediation. So should we be spending the money to segment virtually or physically? And utilizing the tool that we do, the Claroty tool that we do, we're able to do zonal segmentation. So in which we couldn't be able to do that without the Claroty tool.
Sure.
So with zonal segmentation, now we were achieving an entire new security initiative, which is segmentation, right? So continuous monitoring, great. Inventory management, great. But now we can do segmentation. Oh my goodness, right? So now all of a sudden we can take these thousands of systems and we can take 2/3 of them, 3/4 of them, and do virtual segmentation, and we don't have to spend the money putting firewalls in or running fiber or these other things. So we have found that using Claroty in our internal branded program called OpTech Shield, using Claroty gives us the ability to also implement other security initiatives now that we have this information, we have visibility and transparency into how these assets. And so we've been able to do that. So we've achieved micro-segmentation, a very clear view of our compliance obligations. So we have reporting mechanisms. We have these real robust dashboards, security dashboards that we're able to view our progress on all of our security initiatives, and Claroty gives us that insight. Yeah. We had to develop that in R&D with the Claroty Advanced Services team.
Okay. So maybe this is an overly simplistic question, but how complicated is it to kind of put segmentation in place? I mean, is it a money and expertise question, or is there a lot of mapping and a lot of understanding that goes into this equation?
It's both, Mike.
Yeah.
It's both, right? We have an upfront investment in setting it up, learning what we have, filtering, fine-tuning all that information that we have, understanding it, investing in getting it set up to begin with, and then once it's set up, then from an automated standpoint, we can see changes in behavior, and it gets triggered. It sends an alert to our CSOC. We have an internal cyber operations command center, right? And it sends it to them, and then they have run books and playbooks for every type of alert. They immediately reach out to the asset owner, the system owner, and they immediately reach out and they begin the remediation process through our ServiceNow ticketing program, which is connected to our Claroty instance through an API that Claroty provided as well, a secure API, by the way. that was tested and vulnerability tested. And so we're able to manage all of our remediation through ServiceNow as a result of having that automated through Claroty.
Right. That was kind of leads into my next question. Just basically, just how does this all feed into your response activity? Because it's just, I mean, that's the end state you want to reach.
Sure. So yeah, so for the initial response that we have, we do it through our CSOC, right? So they reach out to the system owner, they work with the security teams, they sort of triangulate the immediate response to whatever the alert is. Sure. Like I said, there's run books and playbooks for each type of alert, for each type of system that we have, right? So we know who to call, we know who to reach out to, we know who to reach out to if our primary isn't there. We know what kind of things we do, we know where we have to unplug, we know if we've got backups. Now, the big question and what we're working on next, what's ahead for us is restoration and recovery. Because recovering an OT system is nothing like recovering an IT system. An IT system, you got network, you got servers, you got some storage, you got some applications, you've got a nice backup somewhere, it's all tidy, you go to your backup, your recovery point objective backup, and you restore from that. The OT world is not like that. You've got a very dynamic process to get the plant started back up again, and it's very critical that you follow along in these particular steps. And so that's our next thing, is how do we utilize the Claroty tool to help us in restoration of the OT system that's been compromised. Mm-hmm. Not just backing it up, but the full restoration management process. Sure. And so that's where we're headed next. And again, we do this with Claroty because Claroty offers us the ability to do R&D with their product. And when we initially bought Claroty, I did a 265 question, 7 functional area questionnaire, and I sent it out to all of the competitors. Only 3 responded, and with their answers to all 265 technical questions. And as a result, we understood what Claroty could do for us if we were dreaming down the road. And this was a few years ago, and now we've achieved almost all of those objectives because Claroty can do the R&D component that we needed to really extract the maximum value out of our investment in that tool. We're very happy with Claroty.
How are you dealing with alert fatigue? Is it an issue for your engineers, for your operators? I know in the IT side, it can be a major burden.
Yeah, it was. And fortunately, we had a team of people. We have a team of people. Once we've got 16 CTDs, so we have 16 threat detection engines in our environment. We got 4 more on the shelf that we're deploying. We probably got 20,000 assets, and so we were producing 20,000 alerts a day. And so we had to start fine-tuning, and it was just roll up our sleeves, and we spent a year, 3 people spent a year going through this, 4 people spent a year going through this process of fine-tuning it down to where 95% of our alerts that we produce now are real alerts that need to be dealt with because we have fine-tuned that feed. And what's nice about it is we can create categories of fine-tuning so that we can take these rule sets and then as soon as we plug in a new system to our monitoring, to our continuous monitoring, we can go to that rule set and it'll automatically detune up to like 80% of the noise that we're getting. And so each time we fine tune, we make it easier for the next thing that we have to fine tune. So that's a big difference because again, that was part of our assessment of the tools that were out in the marketplace, and the other tools in the marketplace required a great deal of manual intervention that would have to be repeated every time we deployed a new connector or a new sensor or a new CTD, whatever the language of that particular vendor was. So this was a big deal for us. This was a major component of our investment.
So just kind of as a last question, obviously I'm sure you have a threat intel feed or you keep your eye on threats. Just what kind of keeps you up at night? What's the major concern? Because like you said, you're managing hundreds of road infrastructure, bridges, etc. This is public safety we're talking about ultimately. So.
For me, and I think probably for a lot of folks like myself, Mike, probably the insider threat, I think, is what worries me the most. Somebody that knows what security protocols we have, knows how to bypass it, has access to some level of credentials, can figure out how to get around our MFA. Some of the speakers earlier today gave us scary stories about how some of these alternative threats and hacks are going on. And just when you thought you've been clever enough to come up with, a pretty good threat detection and threat response environment, you hear that there's ways to get around some of those things. So the insider threat is probably the thing that worries us the most, because those are going to be people who know how to pivot within the architecture. And so that's why internal segmentation is critical to guard against. And that's what we design our system to guard against, is the insider threat. We presume that ignorance is not part of the bad actors' repertoire, that they know what they know and they know more than they should know, and they're going to get in there and do it. So we take that approach. So the insider threat's my answer. Yeah.